Discrete and continuous random variables. Discrete and continuous random variable. Let's talking about the terms. What is discrete and what is continuous? A variable is a quantity whose value changes. Variable, what is variable? First we are learning about this term variable. A variable is a quantity whose value changes. We can say that a variable whose values varies from individuals to individuals and person to person, that calls the variable. If you consider x is a variable, then x can vary from individual to individual, person to person, quantity to quantity, and numbers to numbers. Like as if x is a variable, we can put this value x is equal to 1, 2, or green, blue, etc. Let's talking about the term discrete variable. A variable is a variable whose value is obtained by counting. Discrete variable, that means the variable whose value is obtained by counting. If we can count the number of a variable, then we can say this is a discrete variable. Example: number of students, percentage, number of red marbles in a jar, number of heads, and flipping 3 coins. Students grade level, grade level 1, 2, grade 1, grade 2, okay, flipping 3 coins. Let's talking about the term continuous variable. A continuous variable is a variable whose value is obtained by measuring. If we can measure the value, we can say this is a continuous variable. Example: height of a student in class. It may be fractional, decimal, etc. The height of a student may be 5.1, 6, and 3.1, etc. Weight of a student in class. In class, the weight of a student is students. Maybe the continuous random variable, maybe not, maybe that's exactly the continuous random variable. Time it takes to get to school. Distance, this is marking point. Distance, time, weight, height, students, numbers. Distance traveled between classes. Distance traveled between classes. Okay. Let's talking about the term random variable. Random variable. Let's talking about the terms random variable. Okay. Random variable. What is random variable? Random variable. A random variable is a variable whose value is the numerical outcomes of a random phenomenon. What you need to think: random phenomenon and numerical outcome. Okay, let's talking another more. A random variable is a variable whose value is a numerical outcome of a random phenomenon. Okay. What is random phenomenon? A random variable is denoted with a capital letter. Okay. Random variable denoted with a capital letter. The probability distribution of a random variable x tells that the possible value of x are and how probabilities are assigned to those values. Okay, a random variable can be discrete or continuous. A random variable can be discrete or continuous. Okay, let's talking about the criteria of random variable. First one is discrete random variable, and second one is continuous random variable. A discrete random variables. Talking about the first terms, a discrete random variable. Discrete. Okay. What types of random variable? Discrete. Okay. This is discrete random variable. Okay. It's talking about this definition. Random, a discrete random variable x has a countable number of possible values. Countable number. Conditions are countable. Discrete random variable, which condition is countable number. Okay, countable number of possible values. Let x represent the sum of two dice. If x is a discrete random variable, a discrete random variable is x. You can assign this x as a discrete random variable to represent the sum of two dice. Then the probability distribution of x is as follows. P of x, probability of x, it does means if x varies 2, is x varies the values 2, then the probability of x is 1 by 13. Okay, two dice. X represent two dice. In two dice we got the 36 outcomes. The sample outcomes to 36 outcomes. In x, learn that if x is equal to 2, x varies the value is 2, then probability of x is 1 by 13, 3 or 2 by 36, 4, 3 by 36. Okay. Let's talking about the next term. Okay. To graph the probability distribution of a discrete random variable, construct a probability histogram. Okay, probability histogram. Now we are constructing a probability histogram. Okay. Probability distribution of x given in the probability histogram. In the x-axis we consider this the outcome, and the y-axis we consider the probability. Okay, and look at this histogram. And this is not a diagram, this is an histogram. Okay, if x take values 2, or if x values 2, then you can see that what we see. Okay, you can see that and x take the values 2, the probability of x less than 0.05 and x takes the values 3, and x takes the values 3, the outcomes, the probability of x getting higher, that's like 0.06. Okay, the higher value of probability, that is above 1.15. Okay, that's when x takes the value 7. Let's talking about the terms continuous random variable. Continuous, which is required for continuous random variable. Here you can see that the continuous random variable definition. Okay, let's talking about the definition. A continuous random variable x takes all values in a given interval of numbers. So the recurse point, interval of numbers, given intervals of numbers, take all values, given interval of numbers. What it takes, interval of numbers. Continuous random variable is related to interval of numbers. Okay, the probability distribution example, the probability distribution of a continuous random variable is shown by a density curve. Okay, what is the curve? The probability distribution function of a continuous random variable is shown by a density curve. The probability x, that x is between an interval of numbers in the area under the density curve between the interval endpoints. Okay, the probability that x is between an interval of numbers in the area under density curve between the interval endpoints. Okay, the probability that continuous random variable x is exactly equal to the numbers 2 and numbers 0. Okay, what is the point? The probability that a continuous random variable x is exactly the probability that a continuous random variable x is exactly equal to a number is 0. Okay. Today is normal. Let's talking about the next term in next video. Thanks for watching.